Welcome, GeoTrig. This video is on 4.8 Applications of Trigonometric Functions. The essential question is, what are some applications of trigonometric functions? Let's start. So we're going to learn how to solve a right triangle, solve some problems with bearings, and model simple harmonic motion. First thing on right triangles. So if we want to solve a right triangle, we've done problems like this before. You're given some of the angles or some of the sides, and you just kind of figure out what the rest are using trig functions. So if I told you this example right here, this angle A is 62.7 and side A is 8.4, find the rest of those sides. Well, one thing you can do is you know that sine of 67.2 or 62.7 has got to equal the opposite over hypotenuse, so 8.4 over c. So I can rearrange that to say c equals 8.4 over sine of 62.7. You have to plug that into your calculator because we don't really know something like that by heart. It's not on the unit circle. And what you're going to get is you're going to get c equals 9.45. All right. If you have angle A, C is 90. Angle B is just going to be 90 minus 62.7, so that's going to be 27.3. All right. Well, now we got to get side B. Well, that's going to be cosine of 62.7 equals B over 9.45. So in other words, B equals 9.45 times the cosine of 62.7. You plug that into your calculator, times cosine of 62.7, and what you're going to get is B equals 4.33. So we can write 4.33. So just using trig functions, and you could have done that in a few different ways. Here's another example. We want to, from a point on level ground, 80 feet from the base of the Eiffel Tower, an angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So this is 80 feet away. We want to find A, the height of the Eiffel Tower, and we know this angle right here. Well, it forms a right triangle, so I can say that I can use my tangent function because I want to find opposite and I have adjacent. So the tangent of 85.4 has got to equal opposite A over adjacent 80. Another way to rearrange that is A equals 80 times tangent of 85.4. Plugging those in to your calculator will get you A equals 994.3, but nearest foot says that's going to be 994 feet. Make sure you have your units. All right, let's talk bearings. So in navigation and surveying problems, bearing is used to specify the location of one point relative to another. The bearing from point O to point P is going to be an acute angle, so you're always going to have acute angles. Measure it in degrees. And here's the format for the three parts. So you have your origin usually, and your bearings, if my point here is going north, you've got to know if it's going north or south, and then if it's going west or east. So if it's going like to the northeast direction, and it's a 40-degree angle right there, I say north 40 degrees east. So that tells me going from an origin. North says you're going up, and then 40 degrees says you're going to angle that, and east tells you whether you go east or west. So another example of this one over here, this is north 65 degrees west, would be go north, and then since it says west, you're going to the west, which is the left, and then go 65 degrees. And you get that point P. All right, and same thing if you're going, now if it says south, you go down, and you go 70 degrees east, that means you're going to go to the right 70 degrees. All right, so let's take an example here. Use the figure to find each of the following. The bearing from O to D. So from O to D right here, the bearing, it goes south, and then it goes east, and it goes 25 degrees. So I'm going to go south 25 degrees east. The bearing from O to C would be right here, and it goes south first, and then it goes west, and it goes, well, not 75 degrees, don't fall for that trap. It's the complement of 75, because 75 minus 90 is going to be 15. So 15 degrees west. There you go. Now let's talk simple harmonic motion. So an object that moves in a coordinate axis is in simple harmonic motion if its distance from the origin d at time t is given by either of these functions. So this is something that's moving up and down, or it's oscillating. This is simple motion. This is as basic as it gets. The motion has amplitude A. The maximum displacement of the object, so that's the maximum displacement, is the amplitude. That's how far it's like moving up and down. The period of the motion is the period that we have done in similar functions. 2 pi divided by w, and w was basically b, and we were talking the last few units. Let's see, the equation of the cosine function. So, one thing to note, this is in time t. So when we're talking about the motion of an object over time. So the variable instead of x, we're using t because we're talking about time. And d instead of y because d is the distance. So when we're using real problems, we don't always label them x and y. So let's try an example. A ball on a spring is pulled 6 inches below its rest position and then released. The period for the motion is 4 seconds. Write the equation for the ball's simple harmonic motion. All right, so I want to kind of draw a graph of that. It'll help me out. So where does the ball start? So I'm going to call the rest position right here at the origin. And the ball is pulled 6 inches below the rest position. Actually, yeah, so it's going to be pulled down 6. I'm going to say negative 6. And then it's released. So it starts down here. And what's going to happen is that over time it's going to start springing back up. And then this is simple motion. It's going to go up to positive 6. And then it's going to bounce back to the ground. And the ball on a spring is going to bounce back up. And you're going to have this kind of shape. Well, the period of one motion is going to be 4 seconds. This is going to be at 4 seconds. So let's find some information that we know. Since this is pulled 6 inches below, that means my amplitude is going to be 6. Now the period is 4 sections. So to find the period, and if we're trying to create the equation for this, unless we can go back a slide to double check this. So to find that, I don't know the name of that W thing. I think it's mu. No, it's not. Wow, I don't know. I'm going to call it W for now. So to find W, your period, the period of the motion is 2 pi over W, where W is greater than 0. So the period is going to be 4 seconds, has to be 2 pi over W. Okay, so that's the formula. We got to find W to plug into the function. So another way to write that is W equals 2 pi over 4, so that equals pi over 2. So I'm going to plug this in. It looks like I have since this starts below, I have a cosine function, but it's an inverse, it's flipped. So my function in this case, if I'm looking at that, I can write a function d equals a, and usually it's 6 times cosine of pi over 2 t. But since it starts at a negative sign, I'm going to make that negative 6. That'll flip the function. So there's my best answer. Now, let's try another one. Okay, talk about frequency in an object. So an object that's in simple harmonic motion has a frequency given by the function, the w over 2 pi. So what is frequency? It's the number of events per time period. Usually we're talking in seconds for some of this. So this example was talking seconds. So an object moves in simple harmonic motion described by d equals 12 cosine of pi over 4t, where t is measured in seconds and d is in centimeters. Find the frequency. So the frequency, if I'm following that last formula, is going to be f is going to equal the w over 2 pi. And so in this case, it's going to equal pi over 4 divided by 2 pi. Another way to write that is pi over, I hate like double fractions, times the reciprocal of that 1 over 2 pi. So those pi's cancel and I get 1 over 8. So that is the frequency. The maximum displacement is how much you move away, and that comes down to the amplitude. So the maximum displacement is 12. Find the time period required for one cycle. So how long does it take for one cycle? Now so basically you're taking, if the frequency is 1/8 of a cycle per second, how much time? Well, to do one whole cycle, that would require 8 seconds, because you do 1/8 of a cycle per second. And that's your answer. Alright, pause the video. Alright, find the bearing O to B. O to B. I'm going north, and then I'm going west, and it's going 40 degrees. That's your answer, and that's it.